Hi everyone. In this video, we are going to discuss about how to solve an inequality by the Wavy-Curve method. So let's take an example here. We have an example x minus 2 times x minus 5 greater than 0. Now let's draw a real number line and see the behavior of this function on the left hand side. That's a quadratic function there, quadratic expression on the left hand side. And we want to see where on the real number line the behavior or the sign of this function changes. So let me first draw a real number line. To solve this kind of an inequality, what we need to do first? First, we need to identify the points on the real number line where the value of the function or the value of the expression becomes 0. Now, what are those points? Those points are called critical points. So, let me write it down. To find the critical points, we have to equate each of the factors to 0. So, if we equate each factor to 0, we have x minus 2, that is the first factor. If we equate that to 0, we get x as positive 2, x equals positive 2. That is one critical point, and the other factor is x minus 5. So if we equate that factor also to 0, from there we get x equals positive 5. So those are the two critical points. So we have found our critical points, x equals 2 and x equals 5, and I have plotted them on the real number line, as you can see. Now the sign of the function will actually change at those critical points. Let's try with some value. First we are going to try with a value which is on the right hand side of positive 5. Let's pick maybe say number 6, right? So see, in the first factor it will be 6 minus 2, that's a positive factor then, and in the second factor it will be 6 minus 5, that is also a positive factor. So both of them becoming positive when I try with a number which is greater than 5. So on the real number line, out of the two critical points, whichever is on the rightmost side, if you go to the right side of that point, right? So you first find out what are the critical points, and then you plot them on a real number line, and then find the rightmost critical point. In this example it is the 5, and on the right hand side of the real number line, meaning right hand side of 5 on the real number line, any number you try with, your expression value will come out to be positive. And that is why I am putting a plus sign there. So that part of the real number line which is beyond 5 is always going to be positive for this example. And then if you think about the real number line portion between 2 and 5, if you pick any number, that zone is probably going to be negative. Let's try that. So let's pick a number 4 maybe. Let's pick 4, which is between 2 and 5. So if you go with 4, look at the first factor. The first factor will become 4 minus 2, that is positive. But the second factor, which is 4 minus 5, that will become a negative factor. So it will be positive times negative. So that means here in this zone, we try with any number, the value of the function will be negative. And then now look at the left hand side of 2. Let's pick a number from the left hand side of 2. So suppose if we go with positive 1, for example, I'm picking a number 1 for x. So now let's try with 1. The first factor will become 1 minus 2, and the second factor will become 1 minus 5. You see both of them becoming negative. 1 minus 2 is negative 1. 1 minus 5 is negative 4. So it will be a negative factor times negative factor, which again gives us a positive value, right? Negative times negative will become a positive value. So for any number which are on the left hand side of the lowermost critical point, the function value again becoming positive. So let me put a plus sign here. So now you see there are 3 zones on this function, on this number line, right? So we have one zone which is right hand side of 5. Any number from that zone will give you a positive value for the function. Then any number between 2 and 5 will give you a negative value for the function, and then any number less than 2 will give you a positive value for the function. So those are the 3 zones on the real number line where we are going to get either positive or negative value of the function, right? Now wherever the function value is becoming positive, we are going to draw an arbitrary graph here, or arbitrary curve, which is called the Wavy-Curve. Again, it is not a graph of the function. Please make this point very clear. It is not a graph of the function. It is actually an arbitrary curve that we draw to indicate whether the value of the function is positive or negative. Now, in the portion of the real number line where the function value is positive, we are going to draw the curve above the real number line. So let me start a curve here like this. I come to the highest critical point there and I stop there. I said okay, because the value of the function on the right hand side of 5 is always positive, I draw a curve above the real number line to indicate that hey, in this zone our function is positive, meaning the value of our function is positive in this zone. You try with any real number in this zone, the function value will be positive. So we draw this arbitrary curve which is called the Wavy-Curve. We draw this curve above the real number line to indicate that the function value is positive in that zone. Now here is the other zone between 2 and 5 where the function value is negative. We are going to draw this curve below the real number line. So now again I am going to continue the same curve. I am going to continue the same curve below the real number line and I come to 2 and make a stop there, right? So just by looking at this curve, this is again an arbitrary curve. It is not a graph of the function. It is just an arbitrary curve that we are drawing here to indicate in which zone of the real number line, in which range or which zone our function value is positive or negative. That's all we are trying to do here. So if you look at the zone beyond 5, that is a positive zone for the function value. Then the zone between 2 and 5, that's a negative zone for the function value. Then again on the left hand side of 2, again the function value is becoming positive. So again what we are going to do, we are going to continue this arbitrary curve above the real number line and we are going to stop right there, because you know it will go all the way to negative infinity or positive infinity, right? So no need to continue this curve anymore. Just from this we can get a clear idea about where the function value is positive and where the function value is negative. And as you can see, wherever this arbitrary curve which is called a Wavy-Curve, wherever this Wavy-Curve is above the real number line, you know that is where our function value is positive, and wherever the Wavy-Curve is below the real number line, the function value is negative. So from here we can easily write down our solution. Now also we need to understand whether we need to include the critical points in the solution. Well, at the critical point the function value becomes 0, but in this case our inequality example that we have taken, it says that x minus 2 times x minus 5 must be greater than 0, right? So the equality with 0 is not a condition for this inequality, so we cannot include the critical points because at the critical point the function value becomes 0. But in our example we cannot take that point because then it will become equal to 0, but we have to find out all possible values of x for which the function value will be strictly positive, meaning greater than 0, right? So we cannot include the critical point, because if you try, say suppose x equals 2, you try x equals 2, the first factor becomes 0, so essentially your function value becomes 0. So we really cannot take any of those critical points. So in this particular example then let's try to write down the solution. The solution will be like this. So we can say okay, then x must belong to these two ranges here. So we can say okay, x belongs to the two ranges here. We are going to use the interval notation to indicate them. One zone is from negative infinity up to 2. So we can say okay, one range would be from negative infinity up to 2. Now infinity will always go with parenthesis. Now 2 will also go with parenthesis because we are not including the number 2 in our solution set because of the inequality condition. So then we use a parenthesis, and then another zone would be from 5 up to positive infinity, and infinity will go with parenthesis of course in the interval notation, and 5 is not included in the solution set, so for 5 will also go with a parenthesis, and we have to join them with the union symbol. So this is like two interval notation here and with a union symbol, that's kind of a set notation, and we say that hey, this is our solution set. That means if we try with any value from these two ranges, then the function value will be strictly positive. I hope it made sense up to this point. Thank you for watching. See you in the next video.